Hi, in this video I will be explaining what a hash pointer is and how it works in the context of transactions in Bitcoin on the blockchain. I'll also be explaining what a merkle tree is after that. So a hash pointer is literally just a pointer to where some information or data is stored and the hash of said information. Um, with a hash pointer you can retrieve information and which is the pointer part, and with the hash part you can verify that information to check the validity of that information. So how is this used in the context of transactions? Bitcoin is a transaction-based ledger system. This means that the ledger only records the transactions in their history. It doesn't So the miners follow the transactions and not the accounts or the wallets and their addresses. And every individual transaction and the block are linked to previous blocks with those hash pointers. So when you have Bitcoin in your wallet, it's referred to as UTXO, or unspent transaction output. And when you send that UTXO to another person or another entity, whatever, that will turn to spent on your address, and the person or entity that you sent it to will now have that UTXO. Knowing the order of these transactions like that, being able to trace it back, is a very crucial part of solving the double spending problem. And when miners are mining a new block, they're validating the new transactions, they will trace back through the previous transactions by using those hash pointers to see if these current transactions that they are validating are valid or not. If they are, they will present the block to all the other nodes on the blockchain and to try to get the Bitcoin reward for being the first one, of course. Now, what is a merkle tree? A merkle tree is a binary tree that works with hash pointers. The leaves, which are the nodes at the very bottom of the tree, store the data, and the blocks higher up in the tree store the hash of the children nodes. So you have, for example, you have two blocks here that are leaf nodes. They have data, and then we have one parent node of these two. That one, the parent node, will store the hash of these two leaves, and I will have another set of leaves here with a parent node that has the hash. And then with these two blocks, those are hashes, they will have one parent that is the hash of these two blocks, and you'll go up the tree like that. So the wider the tree at the bottom, the taller it will be as well, right until you get to the root, which is the single block at the very top of the tree. So basically, a binary tree is a tree flipped upside down. And this makes tampering with the data in those leaf blocks very visible, because if you change just the smallest amount of data in those blocks, the hash of their parent will change, and this will make the hash of that parent above that not correct anymore, because you have that parent above it is the hash of these two hashes, and if this hash has changed, this hash should change as well, and so should every hash above that, which is impossible. So it makes the changing of data very visible, which is a big part of blockchains, the immutability, of course. So this is how merkle trees work and how hash pointers work in relation to transactions. I hope you understand it a little bit more. Yeah, that was it.